Let's look at cylindrical coordinates. In 3 dimensions so far, we've been working only with rectangular coordinates. Cylindrical and spherical coordinates are like polar coordinates, except they're for 3 dimensions instead of 2 dimensions. Let's look first at cylindrical coordinates. They are exactly like polar coordinates, except they're for 3 dimensions instead of 2 dimensions. The typical rectangular coordinates for a point are x, y, z. The typical cylindrical coordinates for a point are r, theta, z, where just as with polar coordinates, r equals the square root of x squared plus y squared, and theta is the angle between the positive x-axis, that's this, and the line segment from the origin to x, y, 0. So if this is our point x, y, z, this point down here is x, y, 0. So that means theta is defined in the same way as it is in polar coordinates. And z is just z. Okay, so cylindrical coordinates are exactly the same as polar coordinates, except we throw in a z. So for example, find the cylindrical coordinates of the point with rectangular coordinates 1, 1, 4. There's our point 1, 1, 4. So again, 1 unit on the x, 1 unit on the y, and then 4 units out. 1, 1, 4. Okay, so r is the square root of x squared plus y squared, which is square root of 1 squared plus 1 squared, which is root 2. Theta is pi over 4. That's this angle. And z is 4. So we have root 2 pi over 4, 4. Okay, note that the point in the xy plane with rectangular coordinates 1, 1 is root 2 pi over 4. So notice the cylindrical coordinates are exactly the same as the polar coordinates. It's no coincidence that the point with rectangular coordinates 1, 1 has cylindrical coordinates root 2 pi over 4, whereas the point with rectangular coordinates 1, 1, 4 has cylindrical coordinates root 2 pi over 4, 4. It's no coincidence that these are the same as these, okay? It's no coincidence cylindrical coordinates are exactly the same as the polar coordinates. This happens because r and theta in cylindrical coordinates are defined the same as r and theta in, not rectangular coordinates, but r and theta in polar coordinates, sorry. Thus, if a point with rectangular coordinates AB has polar coordinates CD, then a point with rectangular coordinates ABZ has cylindrical coordinates CDZ. So to find the cylindrical coordinates, we need to look at only x and y. Find the cylindrical coordinates of the point with rectangular coordinates -1, 0, 6. Okay, so x, y, z is -1, 0, 6. Again, we can just ignore the z. Ignore z equals 6. Just look at x and y. xy is -1, 0. Our theta is 1 pi. Therefore, yeah, it's 1 pi because -1, 0 is here. And so our distance r is going to be 1, and our angle theta is going to be pi. Therefore, the cylindrical coordinates r, theta, z are 1 pi 6. So again, just find the polar coordinates of the point with these rectangular coordinates, throw in a z equals 6, and you're done. It's not relevant, but here's the point in 3D, courtesy of GeoGebra's online 3D calculator. It's a little better when you toss in that line, and you can see where -1, 0, 6 is. Let's play the cylindrical coordinates game. I give you the rectangular coordinates, and you give me the cylindrical coordinates. Okay, so here we are, rectangular coordinates game. Oh, a cylindrical coordinates game. Very exciting. So rectangular coordinates, x, y, z, 5, 5, -1. Again, we're going to ignore the -1. So 5, 5, that's going to give us what in polar coordinates? Let's see, 5, 5. The distance is going to be 5 or 2 by the Pythagorean theorem, and this angle is pi over 4. So it looks like 5 or 2 pi over 4, -1. Yep, there it is. How about 0, 3, 1? Okay, so there's 0, let's see, 0, 3 is going to be up here. And so 0, 3, 1, the distance r is 3, the angle is pi over 2, and z stays 1. So 3 pi over 2, 1. How about root 3 over 2, 1/2, 4? There should be a little comma in there. Let's see, root 3 over 2, 1/2. Root 3 over 2 would be about over here, and a half be about over there. Okay, that's what it looks like. So that distance is 1 by the Pythagorean theorem. And this angle theta, okay, this is a 30, 60, 90 triangle, and that angle theta is, it's going to be 30 degrees, pi over 6. So it looks like it's 1 pi over 6, 4. 0, 0, 6. Okay, well, what are the cylindrical coordinates r, theta, z for this point? Again, 0, 0, 6. R is going to be 0, Theta could be anything, really. It doesn't matter what you put in for that, and z is still going to be 6. So yeah, we gave it 0, 0, 6, but really the theta coordinate could have been anything. And lastly, 0 pi, pi over 2. Tricky one. So x equals 0, y equals pi. Okay, it's not an angle, it's just a distance. That distance is pi. Z is pi over 2. So it looks like the r coordinate is going to be pi. That's the distance. Theta is going to be pi over 2. And z is just going to be pi over 2 as well. Okay, that's what we get. Pi over 2, pi over 2. We've been converting from rectangular coordinates to cylindrical coordinates. The formulas we would use to convert from cylindrical to rectangular coordinates are formulas we've seen before. X equals r cosine theta, y equals r sine theta, z equals z. We saw these when we worked with polar coordinates, and we're using them again because, again, cylindrical and polar coordinates, they're basically the same. You just throw in the z. So for example, let's say we want to find the rectangular coordinates of the point with cylindrical coordinates 7, 5 pi over 6, 12. Let's use the formulas. X is r cosine theta, 7 cosine 5 pi over 6, that's 7 negative root 3 over 2, which is negative 7 root 3 over 2. Y equals r sine theta, 7 sine 5 pi over 6, which is 7 halves. And z is just plain 12. So we get negative 7 root 3 over 2, 7 halves, 12. Okay, we can sketch graphs that are given in cylindrical coordinates. Sketch a graph of the equation in cylindrical coordinates r equals 1. Set of all points with r coordinate 1 is a cylinder of radius 1. Because if you think about it in 2 dimensions, that's what it would look like in the xy plane, and so z can be anything. So you just end up with a cylinder, courtesy of CalcPlot 3D, this beautiful program. It's available at that website. Sketch graph of the equation in cylindrical coordinates, theta equals 0. When we graph this in 2D, this is what theta equals 0 looks like. That's for positive r, that's for negative r. So I think we're just going to end up with a plane. That's indeed what we get from CalcPlot 3D. We just get a plane. Basically goes and includes the x-axis and extends vertically up and down forever. Okay, so r squared plus z squared is an equation in cylindrical coordinates. Sketch a graph of the equation. Let's do that. In rectangular coordinates, again, r squared is x squared plus y squared. So we get x squared plus y squared plus z squared equals 4, too many pluses here, which is a sphere. So the set of all points r theta z, satisfying r squared plus z squared equals 4, is a sphere of radius 2 centered at the origin. That's what we end up with. Beautiful.